Hey y'all. So a little science experiment here around building a motion base for doing satellite tracking for the ProSat set of apps. So what you're looking at right now, stepper motor on the bottom, you got it hooked up to a servo that's on the top. Currently a set of Allen wrenches acting as a ballast, a weight that I can go throw around. That then connected over here to a Arduino Yun on the bottom and then a motor control board on the top. And then that connected over here to the power supply right now that's running the little 12 volt. I'm trying to get it run on 5 volt, but I haven't been successful yet. So anyway, what I now have running is if you go over here, that's me. I've just written, I don't know, a few hundred lines of code basically that loads into the Yun, and then have configured the Yun to act as an access point. So I'm currently connected with the laptop there. I set up a set of RESTful interfaces, and what I will then do here, let's go ahead and plug in, have it drive to 100, and let's do something more fun than that. Let's do something like 180, and let's have it go to 45. I'm going to hit return and go for as fast as I can to grab that motor here. Yes, I do this. So I'm going to go down here so you guys can see the motor. Okay, and here we are off to the races. And yep, there you go. You can see that it actually then spun around 180 degrees in azimuth and went up 45 degrees in elevation. And that set of Allen wrenches probably weighs a pound, maybe a little more, something like that. I'm going to try to get something that simulates a Yagi here and actually hook it up once I get it into the actual case that I've been futzing with here. But you can then go ahead and, let's say we wanted to go back to 90 and 22. And you can see, went from 90 degrees up 22. Then you can also send it a reset. So there you go. And what that will do is drive it back around to 0, and then it freewheels the stepper motor so that you could then set it to north, right? So the whole idea here is you take this thing out, you'd set it up, wherever you're going to be, it's going to have a set of levels on it so you can get it level to the horizon. So that gets you your 0 elevation. And then basically all you do is just swing it around with a compass to point at north. And right now it's freewheeling. And then as soon as I come back in and drive it to a position, so I'll drive it to an azimuth elevation again. And let's go to, 1 degree or something like that. So simple. And now with that done, now you'll see it's locked, right? So there's actually torque being put against the motor that'll hold it in place and fix it. It's only when you hit the reset do you then get it to freewheel so you can go back and recalibrate and stuff like that. Pointing accuracy on this thing seems to be within, 3 to 5 degrees, something like that. It's actually the potentiometer on the servo that seems to be the item that is giving me the most problems in terms of accuracy. The stepper motor, it's a 200 standard step. I've got it interleaved right now on microsteps, which means it's getting me 400 steps. So that's actually less than a degree in azimuth. So more than enough pointing accuracy for the kind of stuff we got going on here. Well, anyway, there's an example of the stuff up and running, so sort of fun. A little bit of a science experiment here, but time to start assembling all this stuff, and we'll see what we get in the next installment. Bye.